And as usual, I'm the only person here, so we'll just okay.
Like for number 5, I just like where's the sign come into it?
Okay. You know what? It'll be easier if we do this. So you're talking. You said number 5. Here's what you're doing when you do these. So let's go over number 5 first. So cosecant x, cotangent x. Here's what you're looking for. So if you have a problem with something squared, you're looking to use Pythagorean identity. You have something that has 1 plus or 1 minus, like the ones on the bottom, like number 11, then you're using the conjugates. If you have something like number 5, okay, you have something like number 5, cosecant x, cotangent x. When all else fails, we write everything in terms of sine and cosine. All right, so the first thing we do is we break it down into single things. So this becomes cosecant x divided by cotangent x. You okay with that part? It's a division problem.
You're allowed to just like take any type of function that you want.
This is the one they're giving me. I'm just rewriting it. You okay with that part of it?
Yeah.
Okay. Now, when you say every function you want, everything's related to sine and cosine.
Okay.
Yes, sir.
What is like you said like all else fails, you go to sine?
You go to sine and cosine.
What's going on that's like failing?
If you see something squared, you can use Pythagorean identities.
Is that from like the first day of Pythagorean identity?
That's the first Pythagorean identity.
What I do?
So basically, when you have a checklist, this is what you're looking for when you do this. Okay, let's go way back to the beginning. Number 1, you're looking for a GCF. So you're looking if they all have something in common that you can pull out. Number 2, you're looking for something squared, because that tells you you're looking for Pythagorean identity. And number 3 is when all else fails, write everything in terms of sine and cosine. The reason being is that you can rewrite everything in terms of sine and cosine. You can rewrite everything in terms of sine and cosine no matter what. Because as we went through this the last couple days, tangent is sine over cosine. Cotangent is cosine over sine. Secant is 1 over cosine. Cosecant is 1 over sine. The thing I compare it to is when you have multiple variables, like with systems, and you try to get it down to 1 variable. That's what we're trying to do. We're trying to get it down to 1 trig function. Then it's easier to work with. So for example, if I go back to number 1, so let's start at the very beginning. So we're going to start 5.2 on Friday, which is fine. It's perfectly fine. No, it's fine. It's honestly fine. Cotangent is cosine over sine. So you're going to have, and I'll give you the page number before you leave, you're going to have all these in front of you. You don't have to memorize these. You're taking it home. You have all these in front of you. You just have to know how to use it. So is everybody good with the idea that cotangent x is cosine x over sine x? Good with that. Times, what's it be multiplied by? Sine x. Now it's your choice. You can write it over 1 or you can leave it alone. It depends upon how you see things. Now what do the sine x's do to each other? And what are you left with? An x. That's it. Now, my suggestion to you, if you want, and you're going to struggle with it a little bit, plug in something for x in your calculator and see if it comes out to the same thing. So in other words, if you plug in pi over 4, either in radians or degrees, if you do radians, you do pi over 4. If you do degrees, it's 45 degrees. And you do the cotangent of that. And you multiply that times the sine of that. All right, so like the cotangent of pi over 4 is 1. The sine is root 2 over 2. Then you go to your calculator, and whatever your answer is, you do the same thing, and you get root 2 over 2. They come out to be the same, so you know you're correct. Got me? So that's the idea. Now, number 5, and again, you can just do whatever you want. You can't do whatever you want. You just have to use one of the identities. And here's the idea. Before we get into that part, are you good with cosecant x divided by cotangent x? That's what that is. All right, now cosecant x is 1 over sine x. Okay? It's 1 over sine x. That's what it is. That's what we mean by rewriting it. Cotangent, all right, divided by, and there's many, cotangent is cosine over sine. Again, that's on your identity. I'll give you the page number now before I forget. So all those identities, when you have your book at home tomorrow, and I would make sure if it's in your locker, you bring it home, all right, or take a picture of it before you leave. Page 350 in your books. Page 350 in your books is where they're all located. That's where all your identities are in your book. So have that out with you when you take the quiz, because they're all there. All right? Now, when we divide rational expressions, just since you've been doing fractions, you multiply by the what? The reciprocal. So this becomes 1 over sine x times sine x over cosine x. Everybody okay with that? Now, what are the sine x's going to do to each other? Cancel out. And now you have what's left up there, 1 over what? Cosine x. And then from your reciprocal identities we did last week, 1 over cosine, what's the reciprocal of cosine? Boom. That's it. That's all it is. All right. Now there's little things we talked about that are involved as well. For example, if you go down to number 2, pi over 2 minus x, that's the cofunctions. So this starts with a co, so with cofunctions we either add or drop it. So if it started with, we drop it. If we drop co from cotangent, what do we have? Tangent. So this becomes tangent x times cosine x. Tangent x is sine x over cosine x times, again, cosine x over 1. What do the cosine x's do to each other? It's left. And I got sine x over 1, which is just sine x. That's it. Okay? Now, when you get down to squareds, like down on the bottom, there's 2 types of problems that involve 11 and 12. We'll do 12 first, because that's easier. You got to know your Pythagorean identities. Cotangent squared plus 1 is equivalent to cosecant squared x. It's right in your Pythagorean identity. All right? So this becomes 1 over cosecant squared x. Well, the reciprocal identities work for that as well. So what's the reciprocal of cosecant? Sine. This just becomes sine squared over x. And that's it. All right? Then the only other thing on the quiz really is factoring. Really all it is. So when you have expressions like 2 sine squared x minus 3 sine x plus 1. So 2 sine squared x minus 3 sine x plus 1. Yep. So you can just go 2y squared minus 3y plus 1. Factors into 2y minus 1, y minus 1. And then just remember to put it back in. So y represented sine x, so this becomes 2 sine x minus 1. Sine x minus 1. So you treat it just like a variable. Yes, Mary? Cosine squared over 1 minus sine y? Absolutely. Can I show you a short version that's going to make your life a lot easier? All right. Cosine squared y is 1 minus sine squared y. That's the only new thing for today. So if you run into this tomorrow, I'll double check in a second if it's on there. So you rewrite it as 1 minus sine squared y. Okay? This is a difference of 2 squares. So that factors into 1 plus sine y, 1 minus sine y. All right, difference of two squares. So 1 minus sine y. What do the 1 minus sine y do to each other? And you're left with 1 plus sine y. So if you get one like that tomorrow, factor it as a difference of two squares. All right, now I just need to check, which means I'm going to have to start that problem all over again, which sucks, but I'll deal with it. Okay. It's going to tell me I don't have answer choices yet. Oh, good. Okay, nice. All right. It's not going to let me do it. Okay, moving on. Cancel. I'm going to go here. Shared with me. So 2020 quiz 5-1. All right. So there's one factoring. What time is this class? All right. So problem number 1 involves factoring. Problem number 2, we'll talk about factoring out of GCF. Problem number 3, factoring, same thing. Writing in terms of sine and cosine, okay. So, okay. Use a blank piece of paper for this. All right. Oh, one more time. Cosecant x minus cosecant x sine squared x. Okay. Now, this is why we gave you the steps to 1, 2, and 3. Okay? See how they both have a cosecant x? That's why that's your first priority. When they both have the same thing, pull it out. So since they both have cosecant x, and we're going to change this to cosine squared x, sorry. This is what happens when I try to think of things on my head. Sorry. So it's cosecant x minus cosecant x cosine squared x. So they have the same thing, so cosecant x. And then when you factor that out, everybody good with that being 1? Everybody good with that being minus cosine squared x when you pull it out? So you factor out of GCF. Good? All right, now Pythagorean identities. As soon as you see 1 minus sine squared and 1 minus cosine squared, it's its cofunction. So the cofunction of cosine squared is sine squared. You got me? So this becomes cosecant x sine squared x. Everybody good with that? Now, cosecant x, and this goes to write everything in terms of sine, is 1 over sine x times sine squared x. And when we're done with that, we end up with sine x. All right. So I'm telling you, when you take the quiz tomorrow, what involves factoring that we'll talk about in a second? Second one involves factoring. Third one involves writing everything in terms of sine and cosine. Fourth one is a factoring problem. And the fifth one is involving everything in terms of sine and cosine. All right, I cannot stress enough. Sine squared plus cosine squared equals 1. Tangent squared plus 1 equals cosecant squared. Cotangent squared, dang it, secant squared. Cotangent squared plus 1 equals cosecant squared. You need those three to be successful, and you need to know what they look like in different forms. Because as you're jotting that down, all right, cosecant squared plus x plus 3 cotangent x plus 1. Will that work? Yes. Cosecant squared x plus 3 cotangent x plus 1. You with me? Okay. You always change the one that's squared. So Pythagorean identities, cosecant squared x is equivalent to cotangent squared x plus 1. So I replace that with cotangent squared x plus 1 plus 3 cotangent x plus 1. So you're going to have to use Pythagorean identities. What's 1 plus 1? There we go. Cotangent squared x plus 3 cotangent x plus 2. And now you factor that like we talked about before. All right. Good. All right. Well, then you would factor that out. So then you would write cotangent x plus 2, cotangent x plus 1. So in other words, there's two different types of directions you'll have. All right. One direction will say simplify, and one will say factor. All right. One will say simplify, one will say factor. This is an example of one that will say simplify. You got me? Because basically you should get down to that. When it says the factor, all right, when it says the factor, your answer should look like that. Make sense? Because this is what we're going to use not in the next unit, but the following unit to solve equations. That's what your friends in honors are doing now, or they'll be doing before we do this switch. All right? All right. So if you look like from that homework, number 4, cosine x 1 plus tangent squared x. 1 plus tangent squared x, all right, is secant squared x. And then you have to know secant squared x, cosine x times 1 over cosine squared x. And then simplify from there. That's the difference in the two problems. All right. And then it may put it in a different format. So if you have, and we'll give you this one, if you have something like this, all right, everybody got that needs it? So if you have some conglomerate like this, tangent x, secant squared x, plus cotangent x, sine x. All right. So tangent x, secant squared x plus cotangent x, sine x. There's a lot of trig functions there, but they don't have anything in common, so we're not going to factor it. See the difference? So basically, if you can't factor anything, you then go into writing everything in terms of what? Sine and cosine. So tangent would be sine over cosine. All right. Secant would be 1 over cosine squared. Cotangent would be cosine over sine. All right. And then times sine over 1. And then what would the sines do to each other? Cancel out. You'd end up with sine over cosine cubed x plus cosine x. Something like that. All right. So make sure you know the difference. It's short tomorrow. There's only 5 problems. Only 5 problems. Okay? So it's short. All right, so tomorrow take the quiz. Friday, if you want to pay attention to the live stream, we're going to start 5.2. But basically, that gives you a checklist of everything in the front. There's no notes to really take down, and then we will walk through that. All right, because that quiz will be a little more complicated and involves a little more work. And hopefully, after we do that, you'll have a better understanding of this. Everybody good? Okay, if you have any other questions, feel free to message later in the day, either in the posted where I posted the solutions or anything like that. All right.